Hello everyone and welcome to my channel. I am excited to take you through an essential topic for every modern marketer, which is forecasting in marketing analytics. Throughout this presentation or video, we will explore how we can predict trends and behavior using powerful analytical tools and ultimately turning data into a proactive strategy. Let's begin with the basics. What is forecasting in marketing? Forecasting is the process of predicting future events based on historical data. Whether it's sales projection, customer demand, or marketing budgets, accurate forecasting allows businesses to plan ahead, reduce risk, and make data-backed decisions. It's the difference between reacting to market changes and being one step ahead. Next is regression models. Regression models are fundamental tools in forecasting. Let's start with simple regression. It analyzes the relationship between one predictor and one outcome. For example, we might look at how ad spends affect sales. It's easy to interpret and is perfect for isolated relationships, but marketing decisions usually involve many factors. So this is where multiple regression comes in. Multiple regression examines the effect of two or more predictors, like price, season, and competition on one outcome. It gives a much richer and more realistic picture, allowing us to understand what matters the most. The next topic is linear models. In forecasting, linear models assume a constant rate of change. This means that for every 1 unit increase in your independent variable, the dependent variable increases by a set amount. It is simple, effective, and is often used as a starting point in forecasting. For example, a steady rise in social media impressions might directly lead to a steady increase in brand recall. However, linear models work best when trends are stable and consistent, which isn't always the case in real world marketing. So that's where the non-linear models come in. Let's look at the formula. It's y equals mx plus b. Here, y is the predicted value, example sales, and x is the independent variable, example ad spend. M is the slope, which means the change in y for each unit change in x, and b is the y-intercept, where the line crosses the y-axis. In the graph zone, we see a straight line passing through all data points. This represents a perfect linear relationship, which um, so, yeah, each increase in x leads to a consistent increase in y. For example, every 1 unit increase in ad spend might consistently generate 2 more units in sales. In Excel, you can use the linear function or function, or insert a scatter plot with a trend line, then check the display equation on chart option to see the linear model. You can also calculate the slope using equals slope um, bracket y range comma x range, and intercept using equals intercept comma open bracket y range comma x range close bracket. So why go beyond linear models? The reason is simple: because the real world isn't linear. Market change, customer behavior fluctuates, and trends don't always follow a straight path. So non-linear models help us to capture those complexities. Things like rapid growth, saturation points, and diminishing returns. They help forecast more accurately in dynamic conditions where the relationship between inputs and outcomes bends, curves, or simply level off. The next is power model. The power model is useful when each unit increase in the input has a multiplying effect on the output. It is suitable for scaling behavior like network reach or product efficiency. The shape of the curve depends on the exponent. It can either steepen or flatten, giving us a flexibility in matching different behaviors. The power model is written as y equals ax to the power b, where a is a constant and b is the exponent. In this formula, changes in x have a multiplying effect on y. Especially it's noticeable when b is greater than 1. On the graph, you can notice the curve that starts flat has become steeper. This reflects the accelerating nature of proportional growth. As x increases, y increases faster and faster. This is useful when modeling network effects, like how reach multiplies with followers. So in Excel, to fit a power model, use a scatter plot and you can add a trend line. Then select the power under the trend line option. Make sure to check display equation and R squared value, which is essential. I will tell you about this later in the video. You can also log transform both x and y and apply linear regression on the log scale for custom control. The next one is logarithmic models. This kind of models are best when the impact of each additional input decreases over time. This is especially true in scenarios like ad fatigue, where the first few exposure to a campaign drive big results, but the same ad repeated over and over has less and less impact. The curve rises quickly at first, then tapers off. The logarithmic formula is y equals a plus b log x. This model reflects diminishing returns, like a large initial gains that level off as x increases. In the graph, we see the line rise quickly, then gradually flatten. This shape is ideal for modeling things like ad fatigue, where the first few impressions drive strong recall but repeated exposure brings smaller gains. In Excel, you can insert a scatter plot and add a logarithmic trend line and display the equation. Excel will automatically base it on the natural logarithm. This lets you to evaluate how quickly your gains taper and whether the further investment in that input is justified or not. Exponential models show what happens when growth accelerates. This model starts off slowly but then climbs rapidly. It's great for modeling viral trends, technology adoption, or product launches, where the momentum builds and multiplies over time. But it is important to remember that exponential models assume continued growth, so we have to apply real world constraint and caution. Um, so the exponential growth is captured by the formula y equals ae to the power bx, where e is the Euler's constant and b controls the rate of growth. On the graph, the curve starts gently but then rises very steeply. These shows viral or explosive growth such as app downloads or word of mouth effects. It's critical for in forecasting fast moving trends, but risky if the market is limited. In Excel, you can create a scatter plot, add an exponential trend line, and display the formula. You can also use the growth function for exponential regression. This helps project future values based on known exponential growth. Choosing the right forecasting model. Each model serves a different purpose. Linear is reliable for trends that change steadily. Power models handle scaling effect, which is perfect for social engagement or campaign exposure. Logarithmic models suit cases like brand awareness, where first impressions matter more. Exponential is ideal for explosive trends such as tech product launches. Choosing the right model improves the forecast accuracy and helps make the decision making easier and accurate. So seasonality, many industries like retail or tourism have sales patterns that follow the calendar. These seasonal patterns can distort predictions if not included. We use seasonal indexes to capture these fluctuations, improving accuracy. Seasonality models are crucial when trends repeat on a regular cycle, like holiday shopping or tourism. For example, sales might spike every December. If we use a linear trend, we would miss that and like risk the under preparing for peak periods or overestimate demands for off seasons. So seasonal model accounts for predictable cycles in data. In the graph, the blue line represents actual sales, which with seasonal fluctuation, and the dotted line follows the underlying linear trend. The repeating wave pattern, it indicates consistent ups and downs. So, for example, higher sales every December and lower in off months. So there is a different way to calculate seasonality in Excel. So if you guys want me to show you the process for like forecasting using every tool I mentioned, you can comment down below and I will do it in my next video. So once we build a model, we need to evaluate it. Remember I mentioned earlier the R squares. So yeah, the R squared tells us how much the variation in the dependent variable is explained by the model. So the closer to one, it's better. And MSE shows how close predictions are to actual results. P-values, they help us determine if predictors are genuinely impactful or just a random noise. But we have to be careful because chasing a perfect fit can lead to overfitting. So the goal isn't to fit your data perfectly, but to create a model that performs well on future unseen data. So forecasting in marketing isn't about guessing. It's about using the data and the right models to make smarter decisions. Whether it is linear relationship or a non-linear curve, knowing how to build, test, and interpret your models give you the power to drive strategy with confidence. Thank you for watching this video, and if this helped clarify the forecasting process, please feel free to like, share, and subscribe. And you can drop your questions in the comment section below. Thank you.